Okay, so today we are going to look at the periodic table of elements. We're going to actually dig into it. Hopefully before this you watch the TED Talk Ed Puzzle as well as the Brain Pop video on the periodic table. So it'll give you just a kind of a heads up as to what is coming. Okay, so turn to page 24 and let's get busy. You're going to need 5 different colors, whether they're markers or highlighters or pencil crayons. I suggest pencil crayons just so they don't cover up any information, but it's all good, okay? So, first up, the periodic table, okay? So Dmitri Mendeleev invented the periodic table in 1869, right on, which included 64 known elements at the time. And he used his periodic table to predict the properties of missing elements, leaving blank spaces within the table for undiscovered elements. Right on. Now, if you look at the periodic table, you can see that it's arranged in a very special way. Most of the solids are on the left-hand side, and most of the gases are on the right-hand side. So take a look at your periodic table. So you maybe want to rip it off of the back of your gray booklet there, and it looks like this, and you're going to see this dark staircase here that divides a periodic table. Okay, everything on this side, for the most part, well, there's lots of gases here, and then on this side is pretty much solids, okay? The elements on the left-hand side only have a few valence electrons, and the elements on the right side have many valence electrons. The periodic table is organized into groups or families. Okay, and those are the columns. Okay, and periods. And those are the rows. Okay, so when we say which family is nitrogen in, we're looking at the up and down column, and if we say which period is nitrogen in, we're looking at the horizontal row. Okay, so that being said, what's a period? A period is a horizontal row on the periodic table. Each row tells you how many orbits an atom has. For example, if you take a look at your periodic table, where's sulfur? Sulfur is right there. Okay, so sulfur is in row 3. It has 3 orbits. Okay, so how can we tell that? Well, if we look at sulfur and we scroll to the left, that's the first, second, third row, third period. Whichever row an element appears in, that's how many shells or orbits it has. So let's start that on our periodic table. So I'm going to write the word period over there, and then I'm going to number them. Okay, so 1, 2, 3, 4, 5, 6, 7. So there's only 7 shells at the most. You're like, Miss Labiuk, what about these ones down here? Okay, well, the lanthanoids and the actinoids, they actually go in here. So this one has 6 shells and this one has 7 shells. Okay. So the next one says, it asks about boron. So can you find boron on your periodic table? Might have to pause. Okay, boron right there. Okay, boron is in which row? The second row, so it's in the second period, so it has 2 shells. Okay, so boron is in row 2. It has 2 orbits. Okay, so if you count from the left to the right, you can also determine the number of valence electrons an atom has. See, these are things my chemistry teachers never taught me. Okay, So if you want to know how many valence electrons an element has, going up to 20, okay, you can just count from the left to the right. So aluminum, we start in the beginning of the period for aluminum, so 1, 2, 3. Aluminum has 3 valence electrons. How many does nitrogen has? Well, find nitrogen, go to the beginning, and then start counting left to right. 1, 2, 3, 4, 5. Nitrogen has 5 valence electrons, okay? So if you take a look at this, notice how the first period only has 2 elements, and the first orbit can only hold 2 shells, or 2 electrons. That's the pattern, okay? Notice how the second period has 8 elements, and the second shell can only hold 8 electrons. Same thing. Third one, only 8 electrons in the third shell, only 8 electrons in the third period, okay? And we go up to 20, okay? And then these get a lot more confusing, so don't worry about that, okay? Okay, so that is what a period is. What is a group or a family? A group or a family is the vertical column on the periodic table, and each column has elements with similar physical properties and chemical properties, and they also have the same number of electrons in their outermost orbit, and we call these valence electrons. So when you built your 20 Bohr diagrams, you would have seen quickly that all the ones in the same columns all had the same number of valence electrons. And they have similar properties just like you do with your siblings and your parents, right? You're all from the same family. You all have some similar traits. Eye color, the way you laugh, the way you walk, whatever it happens to be, okay? So the periodic law is elements arranged according to their atomic number. Turn the page. Let's give this a try, okay? So here is some practice. For each element, I want you to determine the following. What is the period, number of orbits, group, number of valence electrons. Okay, what do you get for magnesium? Oh, pause, and then I'll put the answers in, and then you check your work, okay? Okay, right on. What about for fluorine? Okay, and at fluorine, I'm just going to pause here because for the group, you might call it number 7 or 17. So let's go back to our periodic table and let's number that, okay? So we can number the groups across the top from 1 to 18. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18, okay? So now because fluorine is over here, and it is in the first 3 rows, we can just cover up the number 1 as well. And so if you call it group 17, that's totally fine. We're going to find out the actual name for that family, and then that's the name we're going to use, okay? Okay. Aluminum. Try aluminum. What is answer these 4 questions for aluminum? Carbon, hydrogen, and neon. Okay, there we go. Right on. Turn the page. Okay. So we heard about some of the characteristics of the families on the periodic table, and there are 5 families that we really care about. Okay. So the first one is the alkali metals. And the alkali metals are, not including hydrogen, from lithium all the way down to francium. Okay. So alkali metals have 1 electron in their outer orbit. They bond with halogens. Okay, because halogens are missing 1 electron. They react with water to make alkaline or basic solutions, so not acidic, the opposite of acidic solutions. Okay. Alkaline earth metals, they have 2 electrons in their outer orbit. They bond with chalcogens. It's a funny word. It kind of looks like you should say chalcogens, but no, it's chalcogens. The H is silent. Okay, and they also react with water to produce alkaline solutions. Just they're not quite as reactive. Okay, and I'll show you where all of these are on the periodic table right away. Okay, hydrogen is in a family all by itself. Okay, it has properties of different families. It has 1 valence electron, but it is also a non-metal. Okay, the chalcogen family. Okay, chalcogens have 2, they are 2 electrons short of having a full orbit. They are most likely to bond with alkaline earth metals. Okay, and halogens right beside them, they are 1 electron short of having a full orbit, and they are most likely to bond with alkali metals, because alkali metals have 1 valence electron they want to get rid of. And the last family is the noble gases, and they have full outer orbits. Okay, they do not react with other elements because they are stable. Okay, right on. So now let's take a look on the periodic table and find out where these elements are for these families. Okay, so we're going to start with our alkali metals, and I'm going to grab orange. Okay, you can grab whatever color you want, and we're going to outline. Okay, don't color it in, but we're going to outline from lithium all the way down to francium, because these are our alkali metals. So when you're doing this, just be careful not to color over any important information, so you can still read the atomic mass and the atomic number. There we go. Okay, and I'm going to add a little key at the top here. So I'm just going to make a empty circle, and I'm going to write alkali metals. Okay, so that's the first family we learned about. The second family is the alkaline earth metals, and they're right beside here. So they start from beryllium and they go down to radium. So same thing, we're going to outline that again. Just trying to be careful not to go over top of the names. Okay, so I'm using purple here. Okay, I'm not filling anything in, it's just outlining, that's all, just outlining. Okay, And I'm going to add that here as well. So my outline purple is going to be my alkaline earth metals. Okay. Hydrogen is in a family all by itself. So I normally just give it a quick circle, but I don't have to add it and have a special name. So we'll just leave it like that. Okay. The next one we're going to do is move over to the chalcogens. Okay. So the chalcogens are over here and they start at oxygen and then go all the way down to livermorium. So I'm going to outline. Okay, remember I'm not filling anything in. Okay, I'm going to add that to my table as well over here. Okay, so these are my chalcogens. Okay, so these ones are missing 2 valence electrons. And how we know that is because every element on the periodic table wants to be like whatever noble gas it's closest to. So oxygen is closer to neon than it is to helium. It's much easier for oxygen to gain 2 electrons than for it to get rid of 6 valence electrons. That's a lot more work. Atoms are very lazy, okay? Lithium over here has 1 valence electron. It's much easier for it to get rid of 1 than for it to try and gain 7 valence electrons, okay? So it is going to try and get rid of 1, so it can be stable like helium, whereas the elements over here want to gain to be closest to their noble gas, okay? So on that note, here we go. Halogens is the next one, and it starts at fluorine. Ugh, I don't like this color that I chose. That's okay. Okay, because I can tell when I'm going by the atomic number, it's covering up the number too much. I don't like that. Okay. Okay, so I've outlined my halogens. Whoops. Add that to my table here. My key halogens. Okay. And then my last one is the noble gases. Okay, so that includes helium and goes all the way down to an inoctium. Okay, so these are the 5 families. So I'm going to add that to my key too. So an empty circle, noble gases. Okay, so these are the names of the 5 families that we need to know. We don't need to refer to them as group 1, 2, 16, 17, and 18 because we should refer to them by their family names. Okay, we can put aside our periodic table for now. And can you turn it over? And I'd like you to try the following 10 questions. So find this element on the periodic table and then circle the correct family that it belongs to. Okay, pause for a second and try it out and then come back and answer the questions. Okay. There we go, right on. And that is it for today. Nice job.